Okay, so that's it. The title of the talk, Trust Issues, Trouble in Package Paradise, and that's what we're going to be talking about. So as always, my name is Jacek Królikowski. I used to work for these guys, and now I work for these guys. You can find me online at Nietaki on GitHub and Twitter, and also on the Elixir stuff, and everywhere else as well. And I'm going to start with a bunch of disclaimers because I like disclaimers. So I'll be talking about security, but I'm not an expert on security by any stretch of the imagination. So if you hack my email, it doesn't mean anything. I'm just talking about the subject because I'm interested in it. The other disclaimer is I'm going to be saying we probably a bunch of times. And when I say we, I don't mean all of us in the room or all the community. I just mean that I think it's a pretty standard approach, what I'm talking about, and pretty common sense one, and many people probably do stuff this way. And I might be talking a bit fast, but that's because there's a time limit. I don't want to keep you guys over, and I have a live demo, which might go wrong as well, so I need some time for that. Okay, so prototyping. I like prototyping on the Beam. It's a lot of fun, but by the time we get to the production stage, the requirements we have from the software we're writing are slightly different. So at the beginning, it can be fast and furious. We can do whatever we want. But by the time we have some user data, we're handling their personal information, maybe their payment information, we can take money off their accounts. It's important that no one can get into our data, no one can mess with our system. So we need to have something that I would call reasonable security. And there's no good definition of reasonable security. I would just kind of have it as an opposition to security by obscurity. So security by obscurity means we're relying on people not knowing how our system works for the security. So like if they knew how it worked, they would be able to attack it. Whereas reasonable security, the way I understand it is if there was someone with my sort of skills and knowing how my system worked, they still can't attack it unless they have the right keys or whatever. So when we get the reasonable security for our production systems, we of course look at the infrastructure. So, well, we need some firewalls. We need to make sure that all the traffic is restricted. Is it all hosted on updated machines so we don't have any old packages that bring us vulnerabilities? We have traffic over SSL for the users, maybe between our app and the database, if it's not all in a cutout network. We probably maybe review our code because there might be some stuff from the prototyping stage where it's like we were cutting corners. Some of those corners were okay to cut, but some of those, like the code we might need to update, make sure there's authentication everywhere. But one thing that we don't frequently do is review the code or the libraries that we're using. And, well, that's kind of, I don't know, standard approach, but it's a little surprising to me. Like, any code that you get from a library and you put in your system is just as much as your system as the code you wrote on your own. So it has as much access to everything you're touching as the software that you wrote on your own. So, well, let's have a think. What's some reasons not to look into the libraries that we're using? What sort of justifications can we give ourselves for like, I don't need to worry about it. So first of all, the code gets peer reviewed on GitHub, which usually it's true that many of the projects we're using are open source and are on GitHub. But unfortunately, some of the libraries that we might be using might be looking a little bit like this on GitHub. And in case you can't spot the problematic part, it's here. And I'm not saying there's anything wrong with this. I hope it isn't. This is my library, actually. But at the same time, if it is reviewed by someone, it's reviewed by the person who wrote it, and that's probably not good enough. But the main problem here is with package systems like Hex and many of the other ones, there's no real guarantee that what you get in a package is exactly what the people put on their GitHub repository. And just to drive the point home, a while back I wrote this. They wrote this evil left pad package, which looks perfectly okay, squeaky clean on GitHub. And if you get it from HexPM, you can see what it actually does. Okay, another answer you might hear is, that's fine, I only use popular packages. And I would say this is a reasonable excuse to a certain extent. Like if we're using Ecto, for example, well, Ecto is a very popular package, everybody's using it, I know the maintainers, I trust the maintainers. If there's some problem with Ecto, there's some bigger problems than my small application, maybe. But at the same time, like we usually start with using just the big popular packages. But over time, as we have to write features, there's only a limited amount of time. We can only reinvent so many wheels, and we add some more dependencies. Some of them might not actually be as widely used, and also some of the dependencies we have some other dependencies of their own, some transitive dependencies, and there's no saying those are very carefully looked at. And when I was preparing for the talk, I looked at the mixlog files for some of the previous projects I worked on, just to find any interesting examples. And as I was looking through those, I found these lines, which was kind of like at first glance it was kind of worrying. And again, if you can't spot the problematic thing, it's here. So I have a package that just says it's unsafe. But like when I looked into it, it's actually like made by a very reasonable guy and basically auto-generates unsafe functions that raise from the functions that return error or k-tuples. So well, I looked at it. Oh, actually makes sense, but might not necessarily have to. Another thing, I'm too small to be a target. And again, this might be true. Like someone might not be attacking you personally, but unfortunately, it's not that difficult to write some sort of attack that's just going to attack any system that you put it on. Because on Beam we have such good introspection, we can sort of have attacks, have code that's going to work on most systems just as well. So here's an example. I'm going to give you a second to look at it. And what it does is when you put it in the system, it looks through all the compiled modules and finds which of these implement ecto-repo behavior, which basically all of the Elixir apps that talk to a database do. So now I know which module to use to access the database that the person is using, and I can start dumping their data. It's not a problem. Another one. I would spot it if I was getting hacked. I would stop it in time. And to that, I like the optimism, but I'm not so sure about that. There was the article that inspired me to look into this at all is this one by David Gilbertson. I think it's amazing. And if you haven't read it, I thoroughly recommend it, where he goes into details of using small packages and adding them as dependencies to others, how he could easily attack lots of front-end applications, and how easy it is to hide these attacks, how easy it is to make them virtually undetectable. You wouldn't be able to find them unless you were explicitly looking for them. Another excuse not to look at these things could be attacks don't happen in practice, which luckily, for now, it was true for the most part. Like I haven't heard any examples of this sort of thing where like a corrupt dependency was attacking an Elixir app or an Erlang app in practice. But I heard of such situations in other ecosystems. So this is one example of this, where a modified package, what was it called? Event stream on NPM got some code injected to attack a specific application, which, if my notes are right, it was Copay, a secure Bitcoin and Bitcoin Cash wallet. And when it was used in this specific application, it decoded the payload and started stealing people's keys and people's money. So this is some more information from the GitHub issue where this was discovered. Turns out the attacker didn't even have to hack anyone specifically. They just got the access to the repository from the maintainer, who didn't really care about the package anymore, didn't want to spend time maintaining it. And it's very easy to point a finger at the maintainer saying like, oh yeah, they're at fault. It's no one should do this. My conscience is clear. But I don't think this is really a solution. In principle, I don't think open source maintainers owe us anything, and it's even said explicitly, for example, in this document, where it says this software is provided as is without warranty of any kind, including but not limited to fitness for a particular purpose. And if your purpose is not getting hacked, they're not promised it's not going to happen. And also, there's the note written by the maintainer, which also talks about the responsibilities of the maintainer. I think there's an interesting discussion that we can have there. Okay, so I hope everyone is sufficiently scared by now, and we can think about, okay, what can we do? So first and foremost, we need to be proactively paranoid. If we're paranoid retroactively, it doesn't work. It's too late. So let's go through a couple of examples of the simple ideas that we might have. Like, what's off the top of our heads? What can we do? Well, probably we can stop using external libraries, but that's not a solution. Again, if we have the time to reinvent all the wheels, if someone's going to pay us for it, fine. But we don't have this luxury most of the time. We can difficult word, always read all of our dependencies. Which, okay, theoretically, in theory, that's a solution. In practice, there's no time for this. We can get our dependencies directly from Git. And I know some people who do this. But just because you get your code from Git doesn't mean it's good. Like, it can fly under the radar. There's no reason to believe this guarantees you safety. We can force Hex or whoever hosts our packages to do the verification for us. This could be a bigger discussion, but I don't think it is their responsibility, and I don't think it should be their responsibility to do the verification. And I don't think they should have the power to be the oracle that says if something is safe or not. We could do what some of the bigger companies do, where they impound the dependencies. Say you want to start using jQuery, for example. So they get a particular version of jQuery, they screen it using their security team, make sure the code doesn't contain swear words and so on, and put it in their own package repository or something, and then you use this impounded version. And I think this is a good solution if you have the option to use it. Like, it requires a whole bunch of effort. Probably in smaller companies as individual developers, we can't really afford that. We could, in theory, perform some sort of static analysis on all the dependencies, but this is a good idea, but I don't think we have the technology yet. This is not an easy problem to solve. It's not something that we can start doing. I don't think it's something that we're going to be able to practically do for another couple of years. Okay, so what else is there? So let's have a think of what sort of properties would the solution have? Like, what sort of solution do we need? So I think our solution needs to rely on manual reviews. Like I said, like we don't have any static analysis tools that are going to give us enough confidence. There needs to be a human factor involved in making sure that your dependencies are okay. It needs to balance risk versus effort. Like, as I said, you can read all of the libraries you're using. That's a lot of effort, probably gives you a lot of security, but it's not practical. Like, we need to have some sort of balance about how much effort you put in versus how much safe you feel that you're protected from the dangerous dependencies. I think, like, we already rely on the community to a certain extent. And I think we can utilize the fact, if I'm using a library, I'm probably not the only person. Like, we can sort of divide and conquer the problem. Maybe we can use our strength in numbers in some sort of way. I think we need explicit reviews. I don't think the sort of approach that, I saw the numbers on HexPM, this library has a lot of downloads, it's probably fine. Like, this is some sort of vague knowledge. But what I think would be better for us if I could point to something and says, this thing proves that Joseph Alim looked at this package and said it was good. Okay, that gives me more confidence in it. I think it's more valuable information. I think we need a simple trust model, a trust model that we can all understand but also works for our purposes. And just because I trust someone, or just because I think that we should trust someone, like my cousin Mike, he saved my life once, he's not a programmer, but whatever he reviews, I say goes. It doesn't mean you should trust him. Just because I trust you doesn't mean you should trust me, this sort of stuff. We need something that's secure by design. So whatever the solution is, it shouldn't probably work on the way that, we're using this website, and this website says this package is safe, but I can't really prove it to myself in any way. Like maybe the owner of the website just says so, but it's not really like any proof of anything. I think we need a solution that works both for individual developers or small organizations and bigger companies. And if we have all of this stuff, it would be cool if the solution was generalizable. Like if we can solve it for our small ecosystem, maybe we can make something that could work for anything else that uses libraries in a similar fashion. So thinking of all these things, a while back I started working on something that I called Hoplon, and I ordered a logo on Fiverr. And I've been looking at it from up close for such a long time I couldn't see the forest from the trees. So I asked a friend to explain it to me, and he said it's your own decentralized package security audit network of trust. And while this is a complicated sentence, I kind of like it. I think I'm going to keep it. And before I go through how it works, let's get a refresher on public key cryptography. Who here has worked with public key cryptography before? Awesome, lots of people. We're going to do the refresher anyways. I have the slides. The most standard use case that we have, the one that everyone recognizes, is there is a private and public key pair. Private is mine. I don't give it to anyone. Public I can give to anyone. And people can encrypt any plaintext message using the public key pair, and then only I can decrypt it. This is the one use case that we all know. The other one that, from what I heard, like not everyone is familiar with, we can use the same sort of key pair. Oh, maybe I should have mentioned, red is the private one, green is the public one. We can use the same pair of keys to use the private key to encrypt a certain message, sign a certain message, and then anyone who has the corresponding public key can take the plaintext message, take the signature, use the public key, and see if the signature matches. So if any of these things are modified, either the plaintext message, the signature, or the public key, like the verification is not going to be successful. And this is what we're going to be using. So the way I think this sort of system that could help us out could work is all of the users of the system have their own private and public key pair. This is a user of Hoplon, a developer, and what they can do is they can publish audits of packages of specific versions of specific packages, where they say, okay, I have this version of this package, and I looked at it. And I think it's dangerous, or I think it's safe, or I just looked at it so-so and it looks good to me, but I didn't look too closely. And they can put it somewhere on the internet. And also, every user has a bucket of public keys, identities, people that they trust, and they can, from the same internet, they can download audits of the packages that they want to use, the packages that they're interested in, and assuming those are the people that they trust for whatever reason, they can see, oh, some of these packages are reviewed and they look okay. Some of these packages, some of the people I trust said they're not safe, so I'm going to maybe look myself or just don't even bother. And some of these haven't been really reviewed, so maybe these remaining two ones I have to look at on my own. Let's get to a demo. This is an MVP of this is made for the most part and uses actual cryptography and everything. And I'm going to try to show it to you guys live. I made the last changes to the code about half an hour ago, so bear with me if something doesn't work. So here's the situation we have. I'm simulating two different people on my machine. I hope this is big enough-ish. Let's try to make it a bit bigger. Okay, I'm not going any bigger than this. So there's two different computers of two different people, Alice and Bob. They all have their Elixir projects. And let's say the person on the left, Alice, wants to start using Hoplon, wants to start auditing messages, auditing packages. So, not this. So she's gonna add Hoplon as a dependency. That doesn't necessarily need to work this way. This is how it works right now. Where she's going to get the dependencies from GitHub right now, and now if we compile the whole thing, now she has access to a couple of operations that are provided by the tool. Some of these are out of date from my previous experiments with the topic. They're going to get removed soon, but I'm going to showcase the ones we actually want to show. So the first thing that Alice wants to do is create her private public key pair. So all the keys are password protected, so I'm going to enter a password. It's test. Probably shouldn't tell you guys. And now the keys are generated. They're written to a directory on the file system. I chose, using environment variables, a specific directory that I want to use as the Hoplon directory. Usually it would be something like home/.hoplon. But it's all configurable already, and you can have many environments if you want to. And now let's see what sort of packages Alice is using in the project. This looks better when the table fits on the screen, but we can see all the packages that are getting used, and we don't have any audits saying that it's either dangerous or suspicious or anything else for either of those packages. And you can say, like, if you looked at the file before, like the dependencies that Alice uses is cachex and JSON, but the dependencies that those packages pull in are also listed here. Okay, so let's have Alice audit a package. Hoplon audit, which one? Let's say unsafe, because I talked about it before. And like, she wouldn't do it just this, she would look at the code, she would do whatever she thinks she needs to do to make sure that the package is safe. So this is pre-populated from the versions we're using, so I'm going to say, yeah, the version is fine, the hash is fine, hash is something we depend on, and I'm going to say it looks good to me. One other check, I think it makes sense to differentiate between, are you the author of the package, that's why you say if it's safe, or you are somebody else and you say it's safe. So by default we say, like, we're not the author. You can add a comment if you want. And in order to sign the message containing the audit, we need to unlock the private key. So I'm going to type in test. So we store the audits locally on our file system, and also they get uploaded to, like, this is a temporary server. I'm going to move it all to something under its own domain and stuff. Temporary, it's Elixir. It gets uploaded to some central server. It's available for other people to use. So now that Alice has done this, because she's a member of the community, she's recognized by people, she contributes to a whole bunch of open source stuff, so her opinions carry some weight. She tweeted this and shared the fingerprint that represents her keys. So I know if I have an audit that's signed with a public key with this fingerprint, I know it's going to be hers. So I can query for this. Okay, so back to the code. I'm going to copy the fingerprint that she actually has. If I can make the mouse work, your key fingerprint here. We're going to use it in a second. So the same here for Bob. Bob just wants to use some packages and wants to get audits from other people. So we're going to do the same thing. Okay, so now if I do the same thing that I did before, mix Hoplon status, I can see that there's some dependencies, and again, no audits yet. Bob doesn't need his own keys because he's not going to be reviewing anything, but he needs to add a trusted key of Alice. So let's do that. Mix Hoplon trusted keys. Add. There's the new thing I added, fetch, and I'm going to use the fingerprint, and I can give it a friendly nickname just so I can tell the keys apart. So again, it shows you where it saves all this stuff. For example, in Alice's case, I could go to her Hoplon directory. And we could see how this is all stored. Like this is the only thing that's actually documented right now. But we have the keys, we have the config to override the server and store which keys we actually trust, and we store the audits and the signatures in flat files that you can use using other tools. So now for Bob, now that he's what did he do last? He added a trusted key, so now he can fetch the audits for the trusted keys that he has. What it would be? I already forgot. Oh yeah. And this is all nicely documented in the help. So he's going to fetch everything that's relevant to him from the server. You can see there's this audit, and now if he checks the status, we can see, can we? Yes, that the unsafe package has one audit that says looks good to me, and we could have some better information here. Okay, so this is not exactly fascinating. I'm just showing that this is all coded up. It works at least theoretically right now. So let's get back to this. So some technical details, how this works under the hood. This doesn't have any dependencies apart from what we have in Erlang and Elixir. I'm making use of standard Erlang modules of public key, ASN1, CT, and HTTPC for network calls, for API calls. That's not entirely true. I still have a JSON encoder right now, but I'm going to be removing it in the next week or so. I just wanted to have it ready for the conference. We use abstract syntax notation 1, distinguished encoding rules for encoding the messages. I think this is a good choice because we have it in our standard library, and also because it's a pretty cool technology. For those who are not familiar with it, as I was a couple of months ago, it's kind of like protobufs, only older and cooler, and we have it in our standard library, which is nice. And the distinguished encoding rules is just some binary way of encoding it that makes sure that all data has just one canonical representation. All the private public keys are OpenSSL compatible, 4 kilobits in length, password protected RSA keys. When I say OpenSSL compatible, what I mean is you probably have OpenSSL command line tool on your computer right now. You could use this tool that you already have and you probably already trust to both create and verify signatures for the audits, and in a similar way, if you have some other code that can parse the definitions of the messages, you'd also don't have to use Hoplon to do the encoding, decoding to the DAR format. These formats are open source and standard. There's no one forcing you to use the tools that I have made. And for the fingerprints, they're pretpretty long. They're SHA-256 key fingerprints. They should make sure that we don't have any collisions, and also the server makes sure that once one key with some fingerprint was added, you can't add another one. You can't use another one with a colliding fingerprint if you wanted to. The server is written on Rax ACE. If you're not familiar with this server web stack, I think it's pretty cool. I think it allows you to do things that are easy to understand and easy to get started, neat server projects from scratch very quickly. I think it's awesome. And if you're interested in that, my good friend Pete Saxton is talking about RaxKit in one of the other rooms right now. So you can still catch the end of his talk. So why should you trust me? That's a very good question, and it already shows me that you guys are getting paranoid, very rightfully so. So first of all, you shouldn't. As I say, like, you shouldn't trust the tools that I built. You should trust the approach that I'm proposing. If you think it's good enough for the case, if you understand how the cryptography works, if you don't see any problems with this approach, you can trust the approach, not the tools. and I think the approach is pretty sound. But if you've been looking pretty closely and trying to take it apart, and I've seen some skeptical faces in the crowd, you might think, well, Jacek, but can't the server withhold audits from us? Like, you only guarantee that the audits that it gives us we can verify locally, and just check the signatures match, and the public keys are the ones we know about. But couldn't the server, in theory, withhold negative reviews? If someone says, well, this package is bad, and I don't want people to know about it, I'm going to withhold it. Yeah, it definitely can, in theory. If I wanted to sabotage my project before it was started, that's definitely what I would do. But also, I don't think it's a problem that we can't fix. I think we can solve it in any of a bunch of ways. Definitely, the first step is going to be me open sourcing the server and saying, you don't have to trust me. You want somebody else to host it, let them host it. Trust the other person, use their server instead. We can have some sort of clever replication to make sure that we're sharing these audits between different servers. So just one being corrupted doesn't mean all the other ones are going to be corrupted. We can do all sorts of things and hopefully not resort to we need a blockchain in a cryptocurrency sort of way. We can have some sort of blockchain, hopefully not the similar one to what we have with cryptocurrencies. But what I wanted to stress, like if we can validate the workflow, if some group of people thinks it's okay, this workflow is going to work for me, I can imagine using it for my production projects. And if we have big enough community, it makes sense to fix these problems. Right now, I think it's important to get the word out there and then see if it's something that we can work with in principle. Then we can close this problem, which leads me to my next point. I need you guys. Right now, it's just one man's crazy idea. Like, I coded it up, no one's using it yet, and just the fact that I sign audits for myself that I can use later on to see that I was sure that some package was right before, that doesn't get us anywhere. I think this starts being valuable if we get a critical mass of people. If enough people in the community look at it, see that it has the functionality that it needs, that it gives them the workflow that works for them. If we have 10% of the community using this, I think we can be in a much better place when it comes to the security of the packages. So I think it would be awesome if you could take a look at the tool, see how the interface feels, see how we would like the interface to feel, like see what you need to make it useful for you in your own case, and we can definitely take it there. Of course, there's some follow-up work to be done. This is by no means finished. I've been sort of rushing it to get it ready for the conference. So there's a whole bunch of cleanup to do. If you go to let's get to this in a second. If you go to the repository, it's going to contain, like, the README contains some information from last year, I think. So, like, I want to have proper documentation. I want to stabilize the APIs and stop using JSON so I can drop the dependency. I want to make the server look good, be under a correct domain, be nicely deployed to a secure place. I want to open source the server. But from all of the other things that I want to do with this, first of all, Erlang rebar support. I focused on Elixir first because that's what I'm most familiar with. But we like, in order for this to be valuable to us, to the whole community, I want to support Erlang and rebar, and I don't think it would be too complicated. As I said, like, the libraries that I'm using here is mostly Erlang stuff, anyways. Porting the logic should be trivial. And I just need the knowledge of how the Erlang build tools work to have it work with this. Some of the other functionalities that I think are going to be very, very important here is key revocation. If I lose my key, someone gains access to my key, but I still have a copy of it, I should be able to publish a message saying, yeah, don't listen to any audits by this key. I don't control it anymore. And it's something that once you know about it, you can't really undo it. And also, we could probably use some utility APIs. Oh, I want to use this package, and I trust these people. Did they audit any versions of this? Because I don't want to do the work myself. This sort of stuff. Diffing between versions. Like the people I work with that they talked about say like, well, I don't want to audit all of Ecto. I audited the previous version. I just want to see the difference between what was added from then to now. So we could have tools for this. Like the first iteration of Hoplon just compared what was in a hex package to what was on GitHub and presented it in a useful way. So we already have the technology in a way. So transitive trust. Maybe it's a good idea. Maybe it's a bad idea. Like if I trust Steve greatly, and he trusts someone greatly, maybe I should trust the third person as well. Maybe not. Maybe we should be configurable. Hard to tell. Like I need your guys' feedback to know these things. So yeah, that's about it. Like the demo that I show you guys is directly usable. The server will be there. The APIs will be changing, but if you keep the latest version, it should keep on working. There's no problem with testing with production because you're just using keys that no one knows about. If you want to see the slides for the links or anything else, they're going to be available here in a second. I didn't make them public yet. And yeah, thank you. Questions?
In the beginning, you just pulled Hoplon repository from GitHub. How do you trust that you pulled the correct one?
This is how I use it right now because I'm iterating on it very quickly. As quickly as I can. But like ideally, the way you would use it is you get it from whatever source you think is safe, whether from Hex or from GitHub, a specific version. And if you want to be properly paranoid, you read all of the code that you got and see if it makes sense. It's a couple thousand lines, most of which are tests. And the core logic is property tested and whatnot, so it shouldn't be terrible. And ideally, it's work that you have to do once to be sure, and then you can keep using it. But yes, this is the sort of approach I'd be looking for.
Thank you. So in the slides, you were relying on me pulling in a fingerprint from someone that allegedly I can trust.
Yep.
So, for example, I didn't know you before today, but if you pretend to be you on Twitter and post a fingerprint, but he's evil and saying like, yeah, this package is good, it's going to look like you are the one that actually did that. Have you thought about the scenario where people try to impersonate someone who the community actually trusts, and if the community can kind of revoke the evil one?
So do I understand correctly that the problem that we might have is I might be pulling someone's fingerprint thinking it's, again, Joseph Valim, it's actually somebody else who pretends to be them. I didn't think about this too much yet, but I think we have, like, we can find workflows and tools to solve it. Like we have Keybase, which is made for this specific purpose. When you have this network of this guarantees this guarantees this, and this was put online a year ago and hasn't changed since, so the owner knows about it being there, so you can trust this gist or something like this. And also, like me pulling in using the fingerprint to pull these things in, you don't have to use the fingerprint necessarily. This is just functionality that I added on the plane here. You can get the public key from someone on a thumb drive or whatever else. You can have like a key signing party, or get it from some other place that they put it that they trust, their blog, whatever, and use the public key directly. So if you can figure out a way of getting these things that you think is safe, you can use it.
In the Rust community, there is a tool that does exactly this as well. I could not for the life of me remember the name of it, sadly, but you can look it up later on.
Yeah.
The way they have done it is that they don't have a server. Instead, you put your reviews you put on your GitHub basically, and then you can just point. So as long as you can point it to a source where you can just read the files out, then the tool will work. So they don't have a server, so you don't have the trust the server issue.
Yeah, so like I like this approach. I don't know if it's going to be heard on the recording, but the idea was in the Rust community, it's done where you don't have the server. You trust people's GitHub. And I don't think there's anything stopping us from doing it this way or any other way, because the core thing here, I think, is the format of the audits and the way we sign them, and where you put it. There's no reason why you couldn't have, like, just as you can have multiple servers that you use, and it is just a change in the config, you can have somebody's GitHub profile. You can have an FTP server with open upload that we only put stuff in, and then everyone can get stuff off of. I think whatever approach feels the safest to the community, and I've heard the idea with the GitHub already. Although I'm not so sure if we want to say like, oh, we all trust GitHub, so it's fine. Like whatever approach feels best for the community, we can definitely implement and start depending on it. It shouldn't be a problem.
Would it be possible to publish to document OpenSSL commands for bootstrapping, for instance, trusting the origin your repository, so you can just document which SSL command to use to verify that public key, then you can go from there.
When you say that public key, do you mean any public key specifically?
The Hoplon public key, the Hoplon SHA. Someone can, everybody, people can sign the Hoplon SHA, and then you can just use OpenSSL commands to verify that one. We could definitely do it. Like the examples of the OpenSSL commands, they're not in the documentation, but they are used in the tests that I have. So like using OpenSSL to see the compatibility is already in the tests of the package, and I should probably audit the package that they're going to be using in the end, using the key that you guys know in advance. So you can verify it before you start using it.